Hello everyone. In this video, we are going to discuss binomial theorem, particularly properties of binomial coefficients, concepts, along with previous JEE main questions. So we know that expansion of binomial theorem, x plus a whole power n equal to nc0 x power n plus nc1 x power n minus 1 into a plus and so on. The general term is NCR into x to the power of n minus r into a power r plus and so on. The last term is NCN into a power n. So in this NC0, comma NC1, comma NC2 and so on, NCR, comma and so on, NCN are known as binomial coefficients. These are known as binomial coefficients. So these binomial coefficients we simply write as BC, binomial coefficients. These binomial coefficients shortly written as also denoted by C0, C1, C2 and so on, Cn. So here NCR equal to NC n minus r 2. NCR is maximum. NCR is maximum if this r equal to n by 2 if n is even. If n is even, this is very important. Among all binomial coefficients, which one is maximum? So NCR is maximum if r equal to n by 2 if n is even. And r equal to n minus 1 by 2 or n plus 1 by 2 if n is odd. So this is very important. Which one is has maximum value among all binomial coefficients? For example, maximum of 20 CR occurs when here n value is 20. So when r equal to 20 by 2, when r equal to 10. The next one, very important one, NCR by NCR minus 1. This is equal to n minus r plus 1 by r. I did not provide any proof of this particular identity in the previous video. Now I will derive the proof of this identity. LHS equal to NCR definition is n factorial by r factorial into n minus r factorial. NCR minus 1, it is in denominator. So we'll write in reverse way, r minus 1 factorial into n minus r plus 1 factorial whole by n factorial. So this is equal to C. N minus 1 factorial is cancelled. N factorial is cancelled. This R can be written as R into R minus 1 factorial. So now R minus 1 factorial is cancelled. Now this N minus R factorial can be written as N minus R into N minus R minus 1 factorial. So this term is cancelled. So this gives, sorry, 1 minute. N minus R plus 1 is bigger than N minus R. So N minus R plus 1 factorial can be written as, this can be written as N minus R plus 1 into subtract 1 N minus R factorial. So this is cancelled. So we got that here N minus R plus 1, here R. So this is equal to N minus R plus 1 whole by R. So this identity is very, very important. There are many questions in previous JEE Mains. Another one is NCR plus NCR minus 1. This is equal to, it is also very, very important. N plus 1 CR. You have to take the bigger one. Among these two, you have to take the bigger one. So the proof of this identity is same as above, but still I will prove it. Here LHS equal to NCR is nothing but again n factorial by R factorial into n minus R factorial plus n factorial by n minus R plus 1 factorial into R minus 1 factorial. See, in numerator n factorial is common. So we take n factorial common in numerator. And this R factorial can be written as R into R minus 1 factorial. So you take R minus 1 factorial, R minus 1 factorial, and n minus R factorial is common. Now which terms left remaining? Here we have taken n factorial, n minus R factorial. These two are taken common. Here 1 by R is left. Plus here 1 by n minus R plus 1. So let us simplify this. This gives us n factorial by R minus 1 factorial, n minus R factorial. This is outside of the bracket. Now inside of the bracket, taking LCM, you will get in numerator n plus 1. In denominator, R into n minus R plus 1. Further, we can write it as this is equal to, see, n plus 1 into n factorial is nothing but n plus 1 factorial whole by R into R minus 1 factorial is nothing but R factorial. N minus R into n minus R plus 1 is nothing but n minus R plus 1 factorial. So this is nothing but n plus 1 CR. This particular identity is very, very important. So you please try to prove after watching this video by yourself. There is another identity in binomial theorem using binomial coefficients. That is also very, very important. MC0 into NCR plus MC1 into NCR minus 1 plus MC2 into NCR minus 2 plus and so on. At last MCR NC0. In terms of sigma, we can write as like this. MCK NCR minus K. K is running from 0 to R. This is equal to M plus N CR. This particular identity is very, very important. I will give you a very short proof of this particular identity. MC0 into NCR plus MC1 into NCR minus 1 plus MC2 into NCR minus 2 and so on. I forget to tell you that NCR, this standard form, can also be written as like this. Both are same. And the definition is this, is n factorial by r factorial, n minus r factorial, where r lies between 0 to n. And we define this value 0 if r value is greater than n. Now, how do we prove this identity? So this identity can be proved using a simple application of permutations and combinations, particularly combinations. Here you see, suppose there are m green balls. There are m green balls. And there are n white balls. N white balls. We want to select R balls. We want to select R balls. So there are m green balls and n white balls, and we would like to select R balls. So it is very clear that when we are selecting R balls, you may select 0 green balls and R white balls. So this can be done in MC0 into NCR. And 1 green ball, R minus 1 white balls. Total number is R. So it can be done in MC1 into NCR minus 1. 2 green balls, R minus 2 white balls. This can be done in MC2 into NCR minus 2. So in this way, at last, you can select R green balls and nothing can be selected from white balls. So 0 white balls. This gives us MCR into NC0. So selecting R balls from M green balls and N white balls can be splitted into R plus 1 ways. So total number of ways of selecting R balls from M green balls and N white balls. Equals, this is equal to, we are selecting R balls from total M plus N. So M plus N CR is nothing but the sum of all possible cases. The sum of all possible cases means MCR in MC0 into NCR, MC1 into NCR minus 1, MC2 into NCR minus 2, and so on. So adding all these. So this is nothing but MC0 into NCR plus MC1 into NCR minus 1 plus and so on MCR into NC0. So remember, here sum of these two numbers is R. Sum of these two numbers is R. Means how do we notice when a problem comes? That problem comes under particular this identity. So here sum of these two is R. There are several questions asked in previous JEE Main based on this particular identity. Now I will explain a few previous JEE Main questions based on these identities. So here the first question is sigma I equal to 1 to 20. 20 Ci minus 1 by 20 Ci plus 20 Ci minus 1. Observe, this is an identity that NCR plus NCR minus 1 equal to N plus 1 CR. So 20 Ci plus 20 Ci minus 1 equal to 21 Ci. So therefore, what is 20 Ci minus 1 by 21 Ci? So it gives 20 factorial by 20 minus of I minus 1 means 21 minus I factorial into I minus 1 factorial, and expand this 21 Ci. You will get I factorial into 21 minus I factorial whole by 21 factorial. A few terms will be cancelled. The 21 minus I factorial is cancelled. And this can be written as I into I minus 1 factorial. So I minus 1 factorial is cancelled. This 21 factorial is 21 into 20 factorial. So 20 factorial is cancelled. So this is equal to I by 21. Okay. So assume that this sum is sum S. So S equal to sigma I equal to 1 to 20. This is whole cube is there. So I cube by 21 cube. 1 by 21 cube. You write sigma I cube formula n into n minus 1, n into n plus 1 by 2 whole square. So here n value is 20. So 20 into 21 whole by 2 whole square. 21 whole square will be cancelled. So 1 by 21 into this is 2 tens. 10 square is 100. So here given k by 21. So therefore k equal to 100. So this is the problem based on the first identity that NCR plus NCR minus 1 equal to N plus 1 CR. Moving to next question. This question asked in January 2023. Sigma k equal to 0 to 6. 0 to 6. 51 minus k C3. This is very simple question. So let us expand this first of all. Substitute K0, you will get 51 C3 plus put K equal to 1, you will get 50 C3, next 49 C3 plus 48 C3 plus 47 C3 plus 46 C3. So there are 7 terms, 1, 2, 3, 4, 5, 6, and one more term is 45 C3. Now we want to simplify this using that formula NCR plus NCR minus 1 equal to N plus 1 CR. Here what should be added and what should be subtracted. Okay. So here you see, here I will add 45 C4 and subtract 45 C4. Okay. So now we can apply formula that now you see sum of these two is nothing but 46 C4, right? And adding these two is nothing but 47 C4. So like that, 1 increasing, right? And sum of these two is 48 C4, right? So in this way, you will get 52 C4 minus 45 C4. See, this is very simple question asked in January session. 52 C4 minus 45 C4. Very simple. Next question. Here given that 40 C0 plus 41 C1 plus 42 C2 and so on plus 60 C20 equal to M by N into 60 C20. Okay. So first of all, this 40 C0 value is 1. So I can write this as 41 C0, 41 C0 plus next term is 41 C1, 42 C2, 43 C3 plus and so on plus this is 59 C19 plus 60 C20. So I have changed the first term. 40 C0 value is 1. So instead of 40 C0, I wrote 41 C0. Now using the formula that NCR plus NCR minus 1 equal to N plus 1 CR. So sum of these two terms is nothing but 42 C1. Again adding these two, you will get 43 C2. And again adding these two, nothing but 44C3 and so on. So this you will get. Here you see this number remains same, but only one increased here. So same way here you will get at last 61C20. So this is equal to 61 factorial by 41 factorial into 20 factorial. So we want to express in terms of 60C20. So this 61 factorial can also be written as 61 into 60 factorial by this 41 can also be written as 41 into 40 factorial into 20 factorial. So this is equal to 61 by 41. 60 factorial by 40 factorial into 20 factorial is nothing but 60C20. So this value is m and this value is n. Without expanding, we can do. Here is the formula that NCR equal to, we can write that n by r into n minus 1 C r minus 1. So here 61C20, rewriting this binomial coefficient as 61C41. So this gives 61 by 41. Subtract 1 from here, subtract 1 from here. This is 60C40. Again 60C40 can be written as 60C20. That's it. And there is another question based on the same concept here. Same model. So here you see, first we will simplify the expression which enclosed by the bracket. Okay. So let us take this expression as sum s. So here s equal to, in place of 2C2, you write 3C3 because 2C2 is 1. 3C3 is also 1. So 3C3 plus 3C2 plus 4C2 plus and so on plus NC2. So this is equal to, the sum of these two is nothing but 4C3. And again adding these two is nothing but 5C3. Like that, 1 increasing. So you will get n plus 1 C3. Well, so suppose this expression is sum x. Now what is x? So therefore x equal to, this is n plus 1 C2 plus 2 times of n plus 1 C3. Here outside 2 is there. So I will write n plus 1 C3 plus n plus 1 C3. Again using NCR plus NCR minus 1. This gives n plus 2 C3 plus n plus 1 C3. You please expand these two and simplify, you will get the answer. So here, now the next binomial identity is that we have seen that sigma MCK sigma NC R minus K. Here sum of these two is R. K equal to 0 to R. This is equal to M plus N CR. So this is the most powerful identity on binomial coefficients. Based on this, one question asked in 2023 January session. So given sigma can also be written as like this. It is not in direct. Sigma r equal to 0 to 2022, 22 CR into. See this 23 CR, NCR equal to NCN minus R. So I can write 23C, 23 minus R. Now see sum of these two equal to 23. Here sum of these two, sum equal to R. So using the same concept, here M is 22, N is 23, R value is 23. So this is equal to 22 plus 23, C23. Nothing but 45 C23. This is equal to 45 C22. Very simple question. There is another question asked in 2019 that sum is equal to, now you see, here R, here 25 minus R. So sum of these two is 25. So therefore given sum equal to 50 plus 50 minus R C 25. Okay, just a minute. This is not that way. So I'll rewrite the equation. Given sum S equal to sigma R equal to 0 to 25. The first one is 50 CR into this is 50 minus R C 25 minus R. So here the variable R is there. So we can't apply that formula MCR plus or sigma MC K into MC R minus K equal to M plus NCR. Here we have to simplify this expression sigma R equal to 0 to 25. 50 CR can be written as 50 factorial by R factorial 50 minus R factorial into 50 minus R factorial whole by 25 minus R factorial 50 minus R minus of 25 minus R is nothing but 25 factorial. So here 50 minus R factorial is cancelled. Okay, this is equal to just we have to adjust this sum in such a way that we have to get one binomial coefficient. This is 50 factorial by, you see sum of these two is 25. So into, I will write here 25 factorial by R factorial into 25 minus R factorial. So here multiplied in numerator 25 factorial. So in denominator also we have to multiply 25 factorial. And there is another 25 factorial into 25 factorial. So the first one becomes 50C25. That is constant. It does not involve any variable R. So you can bring it out of the sigma. 50C25. sigma r equal to 0 to 25. This I can write 25 CR. So this is equal to 50 C25 into this sum is 2 to the power of 25. 2 to the power of 25 means sum of binomial coefficients is 2 to the power of n. Here I'll write. Anyway, I'll explain in the next video. 1 plus x whole power n equal to, this is sigma NCR x to the power of r equal to 0 to n. Put x equal to 1. We get left side 2 to the power of n and right side sigma r equal to 0 to n. This is NCR. So sum of binomial coefficients is 2 to the power of n. Here n value is 25. Moving to next question. Here you see the value of r for which 20 CR into 20 C0 plus 20 CR minus 1 into 20 C1. Sum of these two is r. Sum of these two is also r. Sum of these two is also r. And at last, sum of these two is also r. So we can write directly this is equal to 20 plus 20 CR. This is equal to 40 CR. So which is maximum? It is maximum. It is maximum when r equal to 40 by 2. This is equal to 20. So very simple question asked in 2019. And there is another question based on the similar concept. See, this is 31 CK, 31 CK minus 1. So just we'll change each sum into some other format. Given sum S equal to sigma 31 CK. This I will write as NCR equal to NCN minus R. So 31 C N minus R means 32 minus K. 32 minus K. K equal to 1 to 31. Nice. Minus sigma. This is K equal to 1 to 30. And this is again 30 CK. So this is N minus R. NCR equal to NC N minus R. I'm using this formula. So 30 minus of K minus 1, 30 C, 31 minus K. See, sum of these two is 32. And sum of these two is 31. Here both M and N are same. So this is equal to. But remember what is our formula? Our formula is MC0, NCR, MC1, NCR minus 1, plus and so on. Here MCR into MC0. This is equal to M plus N CR. M plus N CR. Here actually we start from 0 onwards. But here what happens? It starts from K equal to 1. So first term is absent. So which means that here this is M plus N is 62. So 62 C 32, right? Minus So here we cannot select 32 balls from either red balls or white balls. So that is not at all possible. So this sum reduces to 62C 32 minus same as here 60C 31. Well, so this gives, we have to simplify this 62 factorial by, here also 31 balls cannot be selected from 30 red balls and 30 white balls. So there is no 30C31. There is no 30C31. 30C31 value is 0. So here 62 factorial by 32 factorial into 30 factorial minus 60 factorial by, this is 31 factorial into 29 factorial. We have to reduce in this way. This is equal to, we have to take 60 factorial common. So 60 factorial taken out. And we have to take 30 factorial common. Okay, 30 factorial. And we have to take 31 factorial. So what is left here? 62 into 61. Because in numerator 60 factorial taken out. In denominator 130 factorial taken out. This 32 can be factorial can be written as 32 into 31 factorial. Anyway, 31 factorial brought outside. So this is 32 minus here 1. This 31 factorial we have taken out. Here we have only 29 factorial. So here you multiply that 30 into 30 by 30. So you will get here 30 by 1. So this is equal to. Now this value is alpha. This is alpha. So therefore, alpha equal to we want that 16 alpha, right? So here you see this is 2 16s and 231. So we want 16 alpha, that's equal to 31 into 61 minus 16 into 30. So you can simplify this. So we have seen that many questions were asked in previous JEE Mains based on 1 concept, minimum 3 to 4%. So question number 9, you please try to solve by yourself using the same method. Here you see sigma r equal to 0 to 5, 6cr, 6c, 6 minus r. So what is the sum here? The sum is 6. So therefore, this is equal to 6 plus 6, c, 6. So this is nothing but 12c, 6. I am moving to the previous question. I will give you just an idea that this AK equal to, you see that this 12C 12 minus K plus I, again use the concept that NCR equal to NC N minus R. So I can write here sigma I equal to 0 to 9, 9CI. Using that concept, this is 12C K minus I, K minus I, plus sigma I equal to 0 to 8, 8CI, and this is 13C, 13 minus of 13 minus K plus I means K minus I. So here, what is the sum? The sum is k. Here, what is the sum? Sum is k. So therefore, you will get here 9 plus 12, 21 ck plus 21 ck. So this you will get 2 times of 21 ck. Rest you can do. Just substitute k equal to 4 ones and k equal to 3 ones and subtract. So don't be afraid by seeing the symbols and big questions. Once you think on it, it will be reduced. It will be very simple question. Thank you.